Hello everybody, and welcome to Chapter 1, Lesson 1 of the Damage Control Assistant Senior Enlisted Curriculum. I'm Lieutenant Timothy Mueller, and I'll be your instructor for this lesson. As you saw in the enabling objectives, we have a couple terms that we have to define first before we actually start getting into the physics and the basics of ship stability. Those terms are stability, G, center of gravity, B, center of buoyancy, capital delta, which is displacement, moment, and moment couple. All of these have been touched on a little bit in Chapter 0 in my previous videos. So I'm going to assume that you already know a little bit about G, B, and delta here. But we're going to go a little bit more in depth with stability, moment, and moment couple in this chapter here. All right, so let's start things off by talking about stability. Stability, by definition, is the tendency of an object that's immersed in fluid to right itself, or basically come back to an equilibrium point. We know several different equilibrium kind of conditions. We have stable equilibrium, neutral equilibrium, and then unstable equilibrium. We'll talk about those later on in this chapter. When it comes to stability, however, in this entire series of videos, we're going to be talking about static stability, which is basically taking a vessel, leaning it over to the side, and saying, what is the tendency of this vessel to right itself back to its equilibrium point, which is straight up and down on an even keel. We also are going to be talking about dynamic stability, which is, in essence, the same thing as static stability. However, we're going to be putting an external load onto the vessel, whether that's a wind coming from the beam, or it's personnel crowding to one side, or a crane hoisting something over the side. Static stability has, and we'll get into this later, a curve of statical stability that looks something just like this. Every ship in every single condition is going to be something different. However, the general shape of the curve is going to maintain something right around there. In dynamic stability, now remember, the ship is still heeling over. So we're going to be looking at the static stability. However, there's going to be some sort of a correction that we're going to have to look at when it comes to this force pushing the boat over or heeling the boat over. So there's no difference in static and dynamic stability when we're looking at the big picture overall when it comes to the ship actually trying to right itself. However, in static stability, there's nothing forcing the boat back over. So it's the tendency for the boat to just right itself in calm water with no wind around it. In dynamic stability, there is a force that's pushing it over. Like I said, beam wind, or putting the rudder over hard, or personnel crowding. So keep that in mind when we talk about static stability and dynamic stability. The next term we're going to be looking at is the center of gravity. Now, if you're not already familiar with the center of gravity, take a look at my Chapter 0 videos, where I talk specifically about the center of gravity and how to calculate it. On the right side of the screen, you'll be able to see the equation for it, just to kind of get your memory jogging. The center of gravity is the point through which all of the forces of gravity in a system can be modeled as acting through. Every single object on Earth is made up of smaller parts, whether it's molecules, atoms, whatever it might be. Every single piece of mass exerts a force of gravity due to its mass itself. So to simplify problems, to simplify calculations, we take all of those forces and we kind of average them out into a single point, and we say, okay, this point is the point where we can model all of gravity acting down through an entire system. Next up, we're going to be looking at two terms simultaneously. We have B, which is the center of buoyancy, and capital Greek letter delta, which is displacement. I talked about this a little bit earlier in Chapter 0, so if you want to refresh your memory, you can look at those videos. B, the center of buoyancy, is the point in the system through which all upward forces of buoyancy can be modeled. And then delta is the force of buoyancy, which is also the force of gravity. Now, we had talked about a system has a certain mass, which multiplied by the gravitational constant exerts a certain force on, if it's on the ground, it exerts that much force, or if it's in water, then it exerts that much force down in the water. Due to Archimedes' principle, which if you're interested in looking at that further, you can look at different YouTube videos. Displacement is the weight of gravity And by Archimedes' principle, it's also the force acting up through buoyancy. So the force acting down through gravity is actually the same as the force acting up through buoyancy. And this is going to cause what's called a moment couple, which we'll look at in a few seconds. Now the final two terms we're going to look at are moment and moment couples. I've already talked about it a little bit in this video, as well as all of chapter 0, so let's kind of just quickly brief what they are. Moment is a force times a distance. The most common example I always give people is think about a wrench and you're trying to get a bolt out. You have a bolt here, and this is the wrench. You are exerting a force on that wrench that is a certain distance away from the axis that that bolt is spinning through. The moment that you're exerting, M, equals F, the force, times the distance. If you double the distance, you're going to double the moment. If you double the force, you're going to double the moment. When you see people trying to break a bolt out of like an engine block or something like that, what do they typically do? They either try and exert more force on the wrench if they have a machine, or what they usually do is try and find a longer wrench. A longer wrench is going to impart more of a moment, which is going to break free that bolt a little bit more easily. Moving on to moment couple. A moment couple is just a pair of moments with equal forces acting in parallel lines opposite each other. So we have a force 1 going this way, then we have an equal and opposite force, F, acting not in that exact same line, but on a parallel line. So you have one going this way, and the other force coming this way. It's acting a distance d away from the axis of rotation. So imagine this is just something that's trying to spin on this axis. The moment couple is the force, just one of the forces, times 2 times the distance. You can also think of it as, what is the moment about this axis? Well, we have 2 moments total. We have a force times the distance, plus another force times the distance. These distances equal each other. These forces equal each other. So we basically just factor out 2, and so we get 2 times force times distance, or force times 2 times distance. So that does it for this quick introductory lesson on ship stability. As you saw, this video is a lot shorter than what we had in Chapter 0. In Chapter 0, I kind of broke things down a lot more, so if you have no idea about center of gravity or center of buoyancy, then you can look at those and really get up to speed. These videos forthcoming are going to be a little bit shorter, so that if you want to refresh your memory on something after you come to the school, or you're trying to just learn something for the first time, you might be able to get the basic gist of something, and then if you want to dive deeper, you can look at other videos on YouTube. So like I said, I'm going to conclude this first lesson in Chapter 1 right now. I'm Lieutenant Timothy Mueller, and I hope you have a great day.